Thank you, Priyanka, madam.
Okay, Priyanka, I will read out that introduction. Dr. Venkatamani, Associate Professor, NIT Warangal. Our interested topics are signal processing for wireless communication, MIMO, OFDM, millimeter wave, and green communication. Dr. V.V. Mani received her BE ME degree in Electronics and Communication Engineering from College of Engineering, Andhra University in 1992, 2003, and PhD in Electrical Engineering from IIT Delhi in 2009. She joined NIT Warangal in April 2008 as Assistant Professor in ECE department, where she has been an Associate Professor since March 2018. Her her area of interest includes wireless communication, signal processing for communication. She has numerous publications in credit in national and international conferences and journals. She is a fellow of Institute of Electronics and Telecommunication Engineers and a senior member of IEEE. A warm welcome to you, ma'am. So please proceed the session, ma'am. Mani, ma'am. Hello, ma'am.
Madam, Kirme, madam, have you given a co-host to Venkatamani, madam? Yes, madam. Thank you.
Okay, okay. So please keep my mic unmute.
Ma'am,
Yeah. So I think you
ma'am,
are,
unmute, ma'am.
yeah, unmuted my thing. Okay. So can you see my screen?
Mani, ma'am.
Yeah, yes, Kiranmai. So I unmuted my mic and also I'm sharing my screen.
Yes, ma'am.
Can you see my screen now?
No, madam. Kirme, madam, please give some co-host to
Ma'am,
Mani, madam.
your co-host now. You can
Okay.
share your
Screen right
PPT,
now.
ma'am.
Yeah, I am sharing my PPT.
Ma'am, are you able to hear me, ma'am?
Yes,
Mani,
yes,
ma'am.
I can hear you. But the thing is, when I am sharing my screen, what? Can you see my screen now?
No, madam.
I am sharing my screen, but I am seeing agenda 5G standards and technologies.
Madam,
హలో కిరణ్మయి
Ma'am.
నేను స్క్రీన్ షేర్ చేశాను.
madam, can you please just close the window again? Reopen the PPT, madam. Once
Okay.
again,
No, no.
once again.
It is saying that advanced sharing options Who can share? Only host, all participants who can share. Sharing when someone else is sharing. So I should click all participants or only host?
All, madam, once if you click the share screen, there is some boards are available. Okay, no,
Yeah,
it's
yeah, I
fine.
am.
It's fine, madam. It's fine, madam. No, it's fine. Okay.
Okay. Yes. Okay.
Thank you, madam.
Okay, Kiran, bye. Okay. So very good afternoon to all the participants. I am very sorry for the little delay because we are held up with some another meeting. And so today my presentation is on 5G communication. That is why the 5G is more famous and why we are moving to the 5G communication. And what are the standards are involved in 5G and what kind of research is going on around the world. Okay. So as you are seeing my screen, the 5G is a worldwide wireless web. Earlier we were at www. Now we are looking for 4Ws. That is world is also worldwide wireless web is added, right? So this 5G communication, if you look at this diagram, you could see that the radiation is from all the buildings. So all devices are connected, all the homes are connected, the roads are connected, and all the mobiles are also connected. That means everywhere, anywhere, if you go, I would like to access my internet, and the information needs to be exchangeable format. That is the main motto of the 5G communication. So this 5G communication, so the agenda of this one is the 5G standards and technologies, the why, what, where, and how I want to go for it, right? So this is why we are going for a 5G communication. The main economic and political needs for 5G communication is so a communication and digital economic policy of India has stated clear objectives for 5G. So that is increasing your GDP and creating employment and digitizing the economy. So for applying these three criteria, that is increasing GDP, creating employment, and digitizing the economy, the Telecom Regulator Authority of India also set clear objectives for 5G, right? So what is their objectives? They wanted to do the digital transformation of industry. That's the one thing. That means nowadays the industry is also connected to IoT, through IoT, and the information is available at the industry level, can be shared across the users, and also this information must be available to every other end of the community. And also we want to maximizing the economic growth. So that means these aims will only be achievable if 5G is designed such that it meets the requirements of all industry sectors. So then what are the technical needs for 5G, right? The technical needs for 5G is the 3GPP. We know very well who is deploying the standards for your communication, for your mobile communication is a 3GPP control. So these 3GPP technologies are capable of meeting today's needs. But we know that the first LTE networks actually were deployed in 5 years ago. And also the data consumption is because we know it is continuously growing at a millions of rate as the consumers are also making more use of the mobile broadband services. Now, the Internet of Things will result in billions of connected devices because of the IoT. Because we want to connect everywhere, anywhere, anywhere in India, anywhere in the world, right? So every form is also connected with the internet, and the human beings are connected with detecting devices. So we can find the health, we can find the growth of your Indian. Like that, all industry components are also connected, industries are connected, your human beings are connected, devices are connected, roads are connected, and vehicles are connected. So we are looking for anywhere, in anywhere. That is the main logo of 5G. And also we know that unforeseen users of 3GPP technologies also continue to emerge. And so what is important when unforeseen users are entering into the technologies, the public safety and automativity are the most important things we should note down. And also there is a constant demand to improve the spectrum and energy efficiency and to leverage the benefits of modern research. Okay. So we know that the spectrum is very crowded nowadays because when the more users are entering into the spectrum, we have to allocate a bandwidth to those users. And it's not possible to increase even further demand of the mobiles because the spectrum is already crowded. And also not only the spectrum is crowded, so when you are going for purchasing of the spectrum, there is an auction by Troy. So we have to purchase the spectrum as well as we have to see the benefits from the modern research. Okay. And also it takes several years to design, build and next generation systems to happen. And also we all know about what the 5G is going to do in India, because the 5G, so Indian government has given a lot of money for research in 5G, and many IITs and NITs are involved in 5G research, especially IIT Hyderabad, IIT Madras, IIT Delhi, IIT Kanpur, and IIT Mumbai. They are sincerely wanted to deploy our own base stations. So till now, we are purchasing the technology from either European countries or from American countries. But for 5G deployment in India, India want to deploy its own technology. We don't want to buy a technology from any other country. So, but when you wanted to do this, can we keep the existing infrastructure as it is without changing the infrastructure? Can we directly go for 5G? That is an important challenge. Okay, so these key takeaways, that is there are economic, political and technical needs for 5G, and the existing technologies are capable of satisfying the today's requirements but not those of tomorrow. That's that we everyone knows, uh, because the applications are going to increase. So down to the line, it takes a long time to design and build the next generation systems. Okay. So then what? Why we are going for 5G? So much more than that just possible. If you look at the 5G vision, the 5G is about, you can see that there are many applications in the first diagram. That is water quality, the smart wearables, smart mobility, car-to-car communication, and there is a smart parking system, utility management, and also we are interested in e-health, traffic priority, and demotics, as well as security and surveillance. That is a connected house, entertainment apps beyond imagination, so augmented reality and smart grids. So these are more than just what we are looking for. The 5G is about. So we are interested in the connecting all the devices into the network. Not only that, there is some security issues because when all the devices are connected to the network, the power capability of your mobile device or the device which you are using that want to connect to the internet is also important. Okay, the security and the power levels are much more important in 5G communication. So then the transport, healthcare, utilities, agricultural, aviation, education, entertainment, and factory automation, etc. These are all important things we have to note it down. And also it is really about connecting the people, but more about connecting the things. Okay. So this has widely varying use cases. In 5G, 5G in the first diagram, you could see the vital role of a communication is very much important, right? Because we want to see many devices are connected to the internet. And as also widely varying performance requirements also. That is also another important. Suppose a small device is connected to the a small device is connected to the 5G, then so it takes about how much power it can take, what is the uh, what is the protocol it has to use, right? So these are all important things, and also varying use cases also and varying performance requirements. So no single technology will satisfy all these requirements. Definitely there are much more many kind of technologies are involved in this. So these requirements will not be meet at the same point in time. That's what the 5G communication is. So there are many opportunities for the engineers who wanted to contribute to the 5G communication. Not only a communication engineer, because the smart grid, right? The electrical people wanted to transmit their information from one grid to the another grid in a smart way, and healthcare people. So they wanted to exchange the information. So these are all connected activities. So there is a lot of growth, and there is also a lot of employabilities available when the 5G is actually coming to India as well. So these requirements will not only be met at the same point in time. Then, so we have to understand what is the difference between 4G versus 5G. So if we have any doubts in between, please stop me in between so that I can interact with the participants. Here, the 4G versus 5G communication. What is more about 5G, right? So we have seen that the 5G is nothing but connecting all the devices. Every device want to connect to the internet. But what the more additions we have to do for existing 4G, that is important. So we know very well the 4G, actually the latency of the 4G is below 10 milliseconds. We have expected, and that is also achieved. What is this latency talks about? This latency talks about when you are making a call to your mobile, to your friend's mobile, how much time it takes to connect your mobile, right? So that means the mobile, when you are making a call, the call goes to the base station, and from the base station it is connected to your friend's mobile. So it identifies that the user is correct, then it makes the protocol to join to the call. So this time to connect from the to the base station to the end user, almost it is nothing but we would see that is a ringing time is 10 milliseconds. That is the one example I'm saying. It's not exactly for every device. For a mobile device, maybe we have to wait for 10 milliseconds of your time to make a call, right? But whereas in 5G communication, the people are interested to go because we are waiting time is more. 10 milliseconds means you can observe the time they taken. But whereas if it is latency is reduced to 1 millisecond, just in one click, just I make a call, that means just give a time to your dial. That's it. So once you dial it, it is directly connected to your end user. So this latency time, they wanted to reduce to less than 1 millisecond. So that you can imagine how at what speed your samplers has to work and your protocols has to execute. The time taken to transfer your signal from one end to the another end is also, there is a lot of innovations has to be carried over, right? So that is the latency perspective. That is the one important difference from 4G to 5G. So here we are interested, here the latency is 10 milliseconds, whereas in 5G the latency is 1 millisecond. Then the data traffic. So the present data traffic at 4G is 7.2 exabytes per month. That's the expected data traffic. But whereas in 5G communication, the 50 exabytes per month in 2021. That means by next year, we are expected that the data traffic will be exabytes. And what is the data rate? So the data rate is, the present 4G is 1 gigabits per second. In 5G, we are expecting 20 gigabits per second. So we know that how to improve the data rate, right? So to improve a data rate, currently I don't have a writing pad. I'm away from the home and away from office. So otherwise, I can give you a brief idea of the data rate and the pulse time taken to carry the information. Right? Just I just give in words. You have to follow me the way I am telling it. So this data rate is actually suppose you take one example of 1 millisecond of a pulse is taken to communicate one bit of information. Okay. So 10 milliseconds of time, or maybe 1 millisecond of time. So I have taken 1 millisecond of time to communicate my 1 bit of information. That means my data rate per second, how many bits you are transmitting, it is 1 by that time. That means 10 to the power of 6 bits per second. That means 1 mega bit per second I am transmitting. So if I further reduce my time from 1 millisecond to, I just told in a reverse, the calculations are wrong. That is 1 millisecond. 1 milli means 1 by 10 to the power of minus 3. So that means 1 kilobit, right? My data rate is 1 kilobit. But whereas my expectation is 20 gigabits. That means 1 bit of information time taken, if you can reduce it to some number, I can achieve 10 gigabits or I can achieve 20 gigabits. Okay. So that means 1 bit of information, if it is reduced to 1 nanosecond, that is 1 Gbps, right? 1 nanosecond, then 1 by 1 nanosecond is 10 to the power of 9. That means 1 gigabit per second. Then you are expecting 20 gigabits per second. You can imagine how much time you have to reduce to make your data rate to 20 gigabits per second. Okay. So that is what, that means the short and pulses, if you can send over the air, you can increase your data rate. Then what is the available spectrum in 4G, and can we achieve this kind of a data rate in 5G, right? So we know the available spectrum is actually the 3 gigahertz spectrum. 3 gigahertz in the sense it goes from a small value of frequency component up to we can do your communication with 6 gigahertz of the spectrum, but the available bandwidth, the exact available bandwidth is from megahertz to gigahertz, 6 gigahertz or below 6 gigahertz. So it is approximately 3 gigahertz of spectrum is available. So with the given 3 gigahertz of spectrum, uh, can you because 5G means all devices are connected. Everything must be connected, right? Is it possible to connect all devices at one time? No, it's not possible. So we have to increase the available spectrum to a higher spectrum. That means at least we need 30 gigahertz spectrum. That is the difference from 4G to 5G. And also 100,000 connections per kilometer. So the connection density. But whereas in 5G, all devices are connected in the sense, it is 1 million connections per kilometer square. That means in a given base station, there are millions of devices are to be connected into the 5G network. That is the difference. 100,000 connections to 1 million connections. You can imagine how much of your data is going into your 5G networks, right? So this is a huge difference from the 4G to 5G communication. Then the 5G maximum theoretical downlink speed, because there is an uplink speed, there is a downlink speed, right? So if you look at the maximum downlink speed, what we are expecting in 5G, in the red bar graph, it is 10,000 megabits per second, right? So that means 10 gigabits per second, at least the maximum data speed is 10 Gbps, not 20 Gbps. The 10 Gbps is the minimum theoretical upper limit speed. This is the minimum, not the maximum. I'm saying the maximum is something different. But we are expecting that the minimum gigabits of speed is available for 5G communication, should be available for 5G communication is 10 Gbps. You can see the from the top to bottom, 3.5G DC HSPA takes 42.2 Mbps, and 4G LTE advanced, it is taking 100 Mbps. Then 4G LTE category 4 is taking 150 Mbps. Now currently we are in 4G LTE advanced, so it takes 1 Gbps. But whereas in 5G, it is 10 Gbps. That is what we are expecting the downlink speed. Okay. So I said what is latency. Then we'll just compare the latency for LTE versus 5G. Okay. So LTE, the minimum is 10 milliseconds. Minimum is 10 milliseconds in LTE. And so if you see in LTE 10 milliseconds, how it is taking care of the 10 milliseconds. So the 4 milliseconds across the antenna, and for the core network, it takes 1 to 2 milliseconds. And for the internet, it takes 5 to 10 milliseconds if in the same country as the customer. So if you are in India and if you are calling to another mobile that is available in India, it takes almost minimum of 10 milliseconds of time. So what is the 10 milliseconds of time? When you are making a call, the call is connected to the base station. So that makes 4 milliseconds. So from the base station, it connects the core network. Maybe you are in another base station, right? So you have to be connected to the another base station. So to connect to that core network, it takes 1 to 2 milliseconds. And from the 1 to 2 milliseconds, suppose you are making a WhatsApp call, then it is to be connected to the internet. So it takes another 5 to 10 milliseconds if you are in the same country. So this is the way we are connecting currently using LTE, that is the 4G. But whereas in 5G, we don't want to, because the latency is much important. And so this latency is 5G service is 1 milliseconds of time, less than 1 milliseconds. So that means within zero point 0.5 milliseconds, less than 0.5 milliseconds, it is connected to the internet and the content is delivered to the end user. Okay. So this is what the difference from the 4G to 5G communication, that is LTE versus 5G communications. Now, if you see why do we need this 5G communication is the downloadable speed. That is ultra high definition movies can be downloaded in seconds. Okay. And also 5G will enable an interconnection of 20.8 billion devices, from door locks to cars to refrigerators. Everything is internet connected, right? The machine is connected, car is connected, mobile is connected, washing machine is connected, all machines are connected. So when the data devices, the data rate is to be deployed into the network is also to be handled very carefully, and the security is the most important one in 5G communication. And especially when you are connecting machine to machine communication is to be enabled in 5G. So we know very well a fraction of second can make your data to last, right? So when the fraction of second is also very much important, and the backbone in building up the smart cities with an IoT infrastructure. That is also another mode of 5G communication. Then the data streaming. So the 5G actually will promote ultra low latency devices, which means that a spectator in a cricket stadium can watch a live stream of an alternate camera angle of action that matches what is going on in the pitch ahead with no delay. Okay, so these are all the 5G motors where we are looking for and what we are doing some kind of a research. Now, if you look at this diagram, that is a general 5G scenario, the architecture, we have, so the base device to device communication. Just look at the middle of your diagram. There is a device to device communication, right? So to happen this device to device communication, so as I said, this device is connected to the base station earlier, right? So now if you make the device to device connection to the base station and it goes to the next end user, it takes some time. So what we are thinking, what the people or researchers are thinking of, deploy a small base station in the existing base stations. So the green ones are small base stations. These green ones are the small base stations. That means small cell areas. Okay. So now the device to connection is device to device is happening from one small cell to the another small cell by without connecting to the original base station. So that's what we are important. because the data speed is very much important. So when you make a call from one main small base station to the main base station, and if it goes to the next base station, the latency cannot be improved. So to improve your latency, we have to deploy small base stations, and also we have to avoid the original base station's connection so that it can directly connect to the another device. That's what the device to device protocol is presently functioning, not presently functioning in 5G communications. Okay, so if you see that there is a line of sight communication, LOS channel, and there is a red path. Okay, so from the base station, what I am seeing is NFV enabled NW cloud. Okay, so this through from the LOS path, that is a mobile is connected. LOS path, it is connected to the base station. So from the base station, it is going to a small core network. From the core network, it is going through, from the core, it's going to the internet. And again, it's going to the core network, and it's connected to the server point. Okay. So this one actually in the fashion of a massive MIMO network communication. And also, if you look at the left-hand side, a small cell network. So what is happening in the small cell network? So directly a small base station is connected to the metro, and from the metro it is exchanging the information with another metro. Okay. So, and also it is connected to the core network, and as well as it is also connected to the base station. This is what has to happen in 5G communication. So this core network is actually, it is of internet and your core base stations are connected in these cell scenarios. Okay. And there is another option for, because we are interested in uh, huge data rate. So that means to improve the capability of your 5G communication, and another technology called visible light communication, VLC. So you can see that visible light communication is actually functioning at nanometers of 780 nanometers speed, and it is also having a gigabit Ethernet port at this point. So they are connected in this Wi-Fi fashion. Okay, and there are wireless sensor networks already available. So these wireless sensor networks are again connected to, these wireless sensor networks are again connected to your computational device. From the computational device, it is connected to the internet and core network, and from the core network to the other networks, like a cloud network, and your base stations. Again, it is connected to the device. It is connected to the other devices which are connected in this whole of this network area. Okay. So that means it is a combination of a wide link and a massive MIMO link, because the massive MIMO link is a blue color link, and wide link is a solid line, and wireless link with a black line. So you can see the wireless link with the black lines, and there is a resource link from base station to the core networks, and a control plane. You could see the control plane, and as well as user plane, right? And a communication link is happening wirelessly. So in some cases, it is connected even through Ethernet port. So this Ethernet port connection is going via the wide link, but rest of all are through only wireless fashion. So that means the signal processing aspect of this wireless communication is very much important here. So when you are connecting your communication from one device to the another device, how the flow is completed in this whole of the network. That is another area of wireless scenarios. Okay, so in this one, multiple input, multiple output scenarios, and a user plane entity, and a network function virtualization, network and network functionalities as a service, a device to device communication. So many areas are connected in this, the whole of this network. Now, if you look at three high-level 5G use case families, okay. So in these use case families, from the top to down, if you see the top to down, there is a gigabytes in a second, right? So in this gigabytes in second, so smart home buildings and 3D video UHD screens, work and play in cloud, augmented reality, industry automation, mission capital applications like example of the health and the self-driving car, and also a smart city and voice enabled devices. So all are connected in this one. Okay. So here the machine type communication and also the ultra reliable low latency communication are very essential services for 5G communication. So why I'm saying URLL is a most important one in 5G, as I said, the latency should be is less than 1 millisecond. So when the latency is less than 1 millisecond, you have to reduce the time taken to transmit your 1 bit of information. So if you are transmitting your signal at 1 nanosecond, even not 1 nanosecond, 1/10 of a nanosecond, naturally I can increase my data rate. But when I are sending 1 nanosecond, less than a 1 nanosecond of a pulse into the communication link, there is always possibility of, because of the multipath communication, the many paths are coming in nature, and all these paths, the each nanosecond of time is very essential to isolate the different paths coming in this structure. Different into this structure. Okay. So now the visual presentation to a beamforming technology is also one of the main important area where people are working. So what is this beamforming technology? What is the beamforming technology in 802.11 AC? If you look at each mobile station or your device is connected through it looks like a beam. Like earlier, it is omnidirectional presentations. That is today's Wi-Fi. It is an omnidirectional presentation. So there is a one base station which is located. Base station is centrally located, and your information is communicated through wherever you present. It is communicated, right? But whereas in beamforming technology, the information is, we want to pass the information to the one device. We want to pass the information to the another device. So we can isolate this beamforming nature. That means, so like a beam, I want to send my information because it is happening through a 5G technology. So this 5G 2020 vision recommendations, if you look at, the latency, the mobility and spectrum efficiency and the user experience data rate, and also the peak data rates, air traffic capacity and network energy efficiency. These are all very important in 5G communication. And also different scenarios will work differently according to the applications. So where we deploy this 5G communication. So all of today's 3G and 4G mobile technologies are based on ITU, that is International Telecommunication Units, that is IMT, International Mobile Telecommunication Standards. So this ITU is established in 2000, IMT 2000, and the first 3G deployments commenced around 2000. Now we are in 2020, and it is also laid down all the specifications how we can go ahead with the 5G communication and who are the stakeholders for the 5G community. Okay, so the standardization process. Who will do the standardization for 5G communication? So if you look at this blue diagram, the deployment plan and market services, technology research corps, vision and framework. And so currently we are in 6 gigahertz spectrum, less than 6 gigahertz spectrum. Can we go for beyond 6 gigahertz technical view? And can we optimize these? Can we optimally use this spectrum? Is all coming under this strategic plan, right? So these spectrum broadband arguments, the technical performance requirements, and the initiation for proposals. So these are all comes under IMT 2020 standardization processes. And there is a World Radio Congress. So every year they go with this World Radio Congress, and they plan for the future enhancements, and also they define the structure as well as the protocols what we are going to use for 5G communications, how much band we have to use, what is the radio framework, and the future enhancement plans, update plans, any other process. If you are interested, not the interested, that is IMT 2020 standards will define the rules That means they are the authority who makes defining the technologies. Okay, and also they are the setting this future also, and what is the vision, spectrum, and technology views are set by IMT 2020 standards. Now we see the different bands, that is the existing mobile allocation and a global mobile allocation are defined by World Radio Congress, that's the last year. The existing bands can we go beyond 6 gigahertz and below 6 gigahertz. So currently in the 4G communication, we are in below 6 gigahertz. But because of the spectrum scarcity and because of the more number of applications and more number of devices are wanted to connect to the internet, we are going for high frequency bands. These are all comes under millimeter wave bands. So these millimeter wave bands, there is a spectral is available at 24 to 27 gigahertz band, and also 37 to 40 gigahertz band, 42 to 42.5 to 43.5 gigahertz band. Like there are many other spectral bands are applicable, are available. So even 81 to 86 gigahertz band is also available. So then there is a 31.8 to 33.8 gigahertz mobile allocation, right? No global mobile allocation is available in this band because this band is given for military communications, and 40 to 42.5 gigahertz, 47 to 47.2 gigahertz band. Okay. So these are the existing mobile allocations they are planning. That is IMT 2020 is planning to give these bands for 5G communications. Okay, so this organization of IMT, that the 3GPP is actually started with GSMA, and 3GPP2 is IEEE standards, and 5G IMT, 5G Americans, that is IMT 2020 promotion group. Like there are many groups who involved in standardization of the 5G communication, that is NGMN, NYU Wireless, and 5G Mobile Communication Promotion Forum, ARIB, and TTA, TTC, ETSI, like Worldwide Research Forum. These are all the 5G forums where they decide the standards. So, and we need, they only approve all the standards of 5G communication. Okay. So this 3GPP is specifying the system, like deploying the recommendations. Who are the companies actually working for this 5G communication? Okay, so this 5G communication in European is ETSI, and Japan is ARIB, and Korea is TTTA, and China is CCSA, and North America is ETIS, and India is TSDA. And also we have many other companies. You can look at these companies who are currently working involved in 3GPP market partners, like TSSTMA, GCF, IR6 Mobile Forum. Like many companies are partnering for your 5G communication as well. They are continuing to contribute towards the 5G communication. And the IEEE is actually the one who defines all the standards, who approves all the standards for your communication protocol. Okay, so then when it will happen and when it will be ready for the 5G communication? Actually, the actual deadline was 2020 is a deadline date for 5G communication, but this date has been chosen more for political rather than for the technical reasons. However, there is a large push the date forward because of the mobile operators rush to the first, and also the 5G open trials, alliance formed by SK Telecom, KT, NTT, Docomo, and Verizon. They have already started their trials, and even in Japan, they have already started the 5G communication. But in India, it takes some more time. We have to speed up the deployment. We have to meet the early deployment objectives and other regulation criteria. Okay, so then how it will happen? So actually the release 13 is completed, and also they've already addressed the objectives of 5G. and more also will follow in release 14. Currently, we are working for release 15. So one example of this release 14 is proximity service enhancements. Like if you look at the right hand side, the car to car communication, right? So this car to car communication can happen even in India as well, but in European countries and in American countries, driverless car communication, the protocol is already defined and also it is tested, and a few of the countries are also deployed this technology, driverless technology. And another one is LTE carrier aggregation enhancement and support for vehicle to vehicle services based on LTE sidling, and ongoing further enhancement of LTE and EMBS. Okay, so one example, if you take the cellular Internet of Things system enhancements and dedicated core networks, enhanced dedicated core networks, user plan and control plane separation, like broadband mission controls. Okay, so these 5G requirements, if you look at from the 3GPP contributions, how they are motivated to go with the 5G communication. One is massive machine type communication and ultra reliable network cooperation and enhanced mobile broadband. So these are the some of the use cases of 5G communications. Okay. So then, what are the barriers? Who is stopping to work towards the 5G communication? So to be successful, the telecom industry must meet with the other industry sectors. What are the other industry sectors? Because every device we want to connect with the internet, we want to connect with the base stations. So the other sectors are actually also asked to give their approvals. The other sectors are transport, healthcare, mining exploration, utilities, and agricultural, aviation, entertainment, factory automation. So you can imagine how many other